Today we're going to be looking at proportional reasoning, and we're going to be solving a problem involving proportional reasoning by solving for the unknown value in the proportion. And I'm going to show you one method of doing this. In this question, we're looking at two stores that are advertising specials on oranges. Store A charges $4.24 for 8 oranges, and Store B charges $5.52 for 12 oranges. However, oranges are sold individually. We need to figure out how much less would 30 oranges cost at Store B than Store A. And we're going to justify our answer by showing all of our steps. Right now, it's hard to compare the cost of oranges because we're given different values of oranges. Store A, we know how much it costs for 8 oranges, and Store B, we know the amount for 12 oranges. But these numbers are different. It would be easier to compare if we had the price for the same number of oranges. Well, let's see what numbers we're working with. We're working with 8 oranges, 12 oranges, and 30 oranges. Can we find a lowest common factor of each of these numbers? And let's think about how that will help us to solve this problem. So we're going to start by listing the factors of 8. 1, 2, 4, and 8. Factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. What is the lowest common factor here? Good. The lowest common factor is 2. 2 is a factor for all of these numbers. Well, why do you think we're looking for a common factor between all these numbers? Well, if we have a common factor, we can easily change the numbers of oranges we are using with whole numbers rather than decimals. Okay, so now we're going to set up this information using ratios and a proportional relationship. So for every 8 oranges, it costs $4.24. Well, because 2 is a common factor, I'm going to use that number for my other ratio. Since we're comparing number of oranges to cost, I'm going to put 2 as the numerator. Well, how did I get from 8 to 2? The number's getting smaller, so we know that we must have divided. 8 divided by what gives us 2? Well, we can do that in our head. 8 divided by 4 is equal to 2. Well, since I said these two statements are equal, whatever we do to one side of the equation, we must do to the other. So we must divide the denominator by 4 as well. So $4.24 divided by 4 is equal to 1.06. This tells us that for every 2 oranges, we're going to spend $1.06. Well, we still haven't answered the question. The question asked us how much did it cost for 30 oranges so that we can compare the value. Well, the reason we use 2 is because we know that we can multiply 2 by a whole number to get to 30. Well, we need to figure out what that whole number is. How can we use division to help us find this missing number? Well, how many times does 2 go into 30? 30 divided by 2 is equal to 15. The opposite of division is multiplication, so if I multiply 2 times 15, I'm going to get an answer of 30. And this number that we're using to multiply is referred to as the scale factor. Because we're multiplying the numerator by 15, what do we have to do to the denominator? That's right, we need to multiply it by 15. So 1.06 multiplied by 15 gives us 15.90. We've just found that for 30 apples, it's going to cost $15.90 from Store A. We're going to do the same thing with Store B, and we're going to use our common factor of 2 to help us get to 30. So once again, we're writing this as a proportional relationship using equivalent ratios. So for every 12 oranges, it costs $5.52. So how much would it cost for 2 oranges? Well, once again, how do we get from 12 to 2? We know the number is getting smaller, so we're dividing. We can do that in our head. 12 divided by 6 is 2. Whatever you do to the numerator, you must do to the denominator. So we're going to divide $5.52 by 6, and we get 0.92. So now we know that for 2 oranges, it costs 92 cents. Can you think about how you could find the price for 1 orange if you needed to? Well, again, we know that 2 is a factor of 30, and we've already figured out the scale factor in the first part of the problem. 2 times 15 gives us 30. So we need to multiply the numerator by 15. Whatever you do in the numerator, you must do the denominator. So I'm going to multiply the denominator by 15, and I get 13.80. Therefore, I know 30 apples at store B cost $13.80. Let's look at all the information we've gathered now. We know the price for 2 oranges for each store, and we know the price for 30 oranges for each store. Does it look like it's easier to compare the price when you have the same number of units? We can clearly see now which store is cheaper based on the same number of oranges. Well, for spending $13.80 on 30 oranges at store B, it's much cheaper than spending $15.90 at store A. This was harder to see when we were given the original question because we had a smaller unit and a lower cost as opposed to the 12 oranges for $5.52. You can see now how comparing the same number of units helps you to better understand the problem. Well, the question said, how much less are we going to pay? Well, store A costs $15.90. Store B is $13.80. Well, how much cheaper is it? We're going to subtract to find out. $15.90 minus $13.80 is $2.10. So we know that we're saving $2.10 by shopping at store B. Can you think of other ways you could have solved this problem? Look at the information we've gathered here. How else could you represent this information? Think about that and check out our next video on the playlist Proportional Relationships.